Now, next thing is refraction through a glass slab. So when we speak slab, it means we are referring to glass slab. This experiment generally we do in the lab. So refractive index and thickness of the glass slab is mu and T. So mu is representing the refractive index of glass and T is representing the thickness of the glass slab. The light ray AB incident on slab, displacement produced in emergent ray due to refraction. Indirectly, we are saying that when light ray AB is incident on the slab and enters the slab, there will be bending of light. So X, that is equal to T sine I minus R over cos R, and T sec X, sec R, that is sine I minus R. So what we are finding in this equation, T is kept as it is. Then we have written sine I minus R as it is, and 1 over cos R is written as sec R. That is, we are using trigonometrical equations. Now refractive index mu is given by sine I over sine R. So now we have to use this composition. So again a glass slab is indicated. AB is the incident ray of light making angle I with the normal, and we are finding that the moment this ray of light is moving from air to glass, it is moving towards the normal, and when it comes to another normal, we will find it is going away from the normal. So CD is going away from the normal, and we are finding BC is bending towards the normal. Now, we find that if AB line is extended up to D and the refracted line is also extended up to D, the distance between the two extensions will be X. So X has got the dimensions of length, and T is the thickness of the glass whose refractive index is mu. When the object in denser medium observer in rarer medium, then thickness of denser medium is T, in which object is at point O. Due to refraction, the image may be seen at point I. So it is a case of real depth and apparent depth. So refractive index is given as real depth over virtual depth. Now to understand this, we consider a beaker or a glass container. In that we add water. So it is filled with water, and we find that a coin is kept on the base of the vessel. So when we view it from air into the denser medium, we find that it is slightly raised up. So from the surface to the bottom, the depth is called the real depth, and from surface to that raised position of the coin, that is called the virtual depth. So it is given geometrically according to the figure that refractive index mu is real depth over virtual depth, and that is equal to AO over AI. And AO is T, so it is T over AI. Virtual depth will be T over mu, where mu is the refractive index. So virtual displacement is indicated by OI, and geometrically it can be estimated by function OA minus AI, and that is equal to T into 1 minus 1 over mu, where mu is the refractive index. Now it is shown in the figure, that is the depth is, or the thickness is AO of the glass slab. Then object is at O, and a ray of light is moving from O towards the surface, and from the surface it is bending away from the normal. That is, the light is going from denser to rarer medium. Mu is the refractive index. So we can say that refractive index mu is equal to real depth, that is AO, and divided by virtual depth, that is AI. This I have explained when I have explained in terms of the beaker or a glass container. That is the coin. If it is viewed from outside, it appears to be slightly raised up, but otherwise it is just at the bottom. So we will find, according to geometrical estimations, that is the real depth is AO, virtual depth is AI, that is equal to T over AI. Now, virtual depth will be T over mu, and virtual displacement, that is OI. So we can say OI will be equal to OA minus AI. We compute the values and we get a function T into 1 minus 1 over mu, where T is the thickness of the slab and mu is the refractive index of the medium in which this phenomena is going on. Refraction through successive slab of different thickness and refractive index. So now we are considering successive slabs, many slabs, not one slab. So through successive slabs of different thickness, refractive index will be taken as mu. Now we find that in the given figure, there are different layers of the slab. One has got the thickness T1, other has got the thickness T2, and other has got the thickness T3. However, the medium is not changing, therefore refractive index is not changing. Refractive index always depends upon the medium. The position of I is indicated, and from the eye we are in position to see the object which is right at the bottom. I have given this example earlier. This object will appear at I. So AO is the real height, but AI is the apparent height. Refractive indexes are not changing, but thicknesses are T1, T2 and T3. So virtual depth AI. Now, according to the figure, we will discuss virtual depth AI is T1 over mu1 plus T2 over mu2 plus T3 over mu3. The virtual displacement OI, that is T1 into 1 minus 1 over mu1 plus T2 into 1 minus 1 over mu2 plus T3, that is 1 minus 1 over mu3 plus and so on. So if we take many slabs, the function will go on proceeding as it is shown. When object and observer both are in the rarer medium. So now we are finding that there is a glass slab with refractive index mu in the figure. The position of I is in the rarer medium, and we are finding here that rarer medium is air and the denser medium is glass with refractive index mu. The thickness of the slab is T. Now we are finding that observer is in air. Observer is in air and object is at point O. So we can see in the figure, that is observer is in the air and object. For example, observer is in air and object is at point O in air as shown in the figure. A glass is there in between observer and object. Images form at point I, refractive index of glass is mu. So virtual displacement is OI, and it is given according to the previous formulas as T minus 1 over mu. Now we come towards an object in rarer medium and observer in denser medium. So the medium changes. Object in rare and medium is rarer medium and observer in denser medium. When observer is in denser medium, observer is seeing the object from denser into the rarer medium. Therefore, the incident ray of light, when emerges out in the air medium, we will find that it will bend away from the normal. So the position of the object will appear at some other place. Now, refractive index of water is taken as mu. Observer is in water. image may be seen at point I when object at point O is viewed. So real height over virtual height is taken as reciprocal of refractive index, that is 1 over mu. Virtual displacement OI will be given as AI minus AO, and that is equal to mu minus 1 into AO. So next, now we can look at the figure, that is I is and the denser medium, and we are watching from denser to rarer medium. So I will appear at another position I. O is the object, and there are two mediums indicated, the water and the air medium. So refractive index is mu, observer is in water, image may be seen at point I when object at point O is viewed. So real height over virtual height is equal to 1 over mu, and virtual displacement will be mu minus 1 into AO.